Every year, millions of discarded tires are stockpiled in the U.S., and every year the demand for noise walls in Colorado grows as neighborhood residents seek relief from noisy highway traffic. You wouldn't think the two problems would be related, but CDOT's Division of Transportation Development, along with Felsberg, Holt, and Ulevig, envisioned a unique solution for both. FHU assisted CDOT with research, material selection, and design of a noise barrier that would recycle waste tires. The noise wall design had to be a permanent and functional structure as it was built to be near a segment of 6th Avenue, a 6-lane highway in Lakewood, Colorado. FHU's innovative design stacked recycled tire treads in a structure that met CDOT's roadside safety and noise abatement requirements. The first of its kind in Colorado, the wall currently provides traffic noise relief for residents living along 6th Avenue in Lakewood.
Developing a functional noise wall using waste tires proved to be a unique exercise, but it turned out to be a great example of sustainable concepts in transportation infrastructure design. It was satisfying in several ways, just knowing that there were concepts out there using recycled tires for such an application, but we were able to dig up a new and unique application using a particular product that I think turned out to be a pretty good application. And the final result ended up being a item that people are familiar with when they look at it, but yet upon closer evaluation, you'll discover that it's very unique. After evaluating several products, we came up with one that nobody had heard of or thought about using previously, and everybody ran with it. The benefits were recognized early on, and there was a lot of momentum to use this particular product in our application. And we ran with it and were able to provide everything that was required for the project pretty efficiently and effectively. And I think the product turned out to be pretty good. The project began as a research project and evolved into a permanent design. So there is a research element to the project, and we're actually currently monitoring the structure that we built. And after a full year of monitoring the project, we'll be able to draw more conclusions on its application on future projects.
Diverting waste tires from the landfill and reusing them for much-needed noise reduction along our highways is inherently sustainable. This new application for use of waste tires meets a growing demand as development continues to increase in areas close to highway corridors.
Colorado engineers are also employing their knowledge to better communities outside of Colorado and in other countries. Let's take a look at how American company engineered a cellulosic biofuels plant in Soperton, Georgia, and their use of unique LiDAR technology for conservation management in Nebraska and Kansas.
Range Fuels of Soperton, Georgia, wanted to produce renewable fuels utilizing wood products from Georgia's large southern pine forests. These products once provided feedstocks for the pulp and paper industry in the U.S., but that industry has moved overseas. To accomplish the vision, American Company supported the early pilot plant testing, assisted with the operations of the next generation testing, and engineered and designed all process systems for the first commercial cellulosic biofuels plant in the U.S. Merrick's multidisciplinary engineering services included process, mechanical, civil, structural, electrical, and instrumentation for all systems designed for the project. As of August 2010, the Soperton plant has produced cellulosic methanol from woody biomass, and Merrick continues to provide technical support for plant operations. This project's cutting-edge technology and first-of-a-kind designs represents the challenging projects that support Merrick's prominence in the renewable fuels industry.
In response to National Energy Policy Directive, Merrick employed state-of-the-art engineering to successfully deliver to Range Fuels the country's first commercial-scale cellulosic biofuels facility. That's satisfying to me, and I think it was also satisfying to the entire team members. We definitely felt that the project was much bigger than we were in terms of getting the country to energy independence.
Biofuels are an important component of a comprehensive new energy strategy. This project advances the design and performance of the thermochemical pathway to bring the sustainable and profitable biofuel to market. The biofuel produced by this innovative process exceeds the requirement to reduce greenhouse gas emissions by 60% and qualifies as cellulosic biofuel as stipulated in the Energy Independence and Security Act of 2007.
The rainwater basin landscape of south-central Nebraska and north Kansas features thousands of lakes and wetlands and is also known as the Central Flyway, a bird and waterfowl migration route hosting 10 to 15 million migratory birds. Unfortunately, during the 20th century, the wetlands here were drained for farming, road construction, and silted in from development. In 2007, the Natural Resource Conservation Service called on American Company to collect LIDAR, light detection and ranging, for 18,000 square miles of the rainwater region. LIDAR technology uses a beam of light projected from an aircraft to the surface of the Earth to create highly accurate elevation information of natural landforms and man-made objects. Merrick provided professional guidance to understand the LIDAR technology and used it as the mapping solution to support natural resources and agricultural management and planning, as well as habitat restoration. Because of Merrick's creativity to design a project that allows its technology to soar, NRCS has been able to take full advantage of the LIDAR data for the benefit of conservation planning, design, and engineering.
American Company provides airborne LIDAR to a consortium of agencies covering 18,000 square miles of the rainwater basin in Nebraska as part of a wetlands restoration program. The area is critical to millions of migrating waterfowl.
Effective conservation requires understanding what is there and using scientific data to protect and manage wildlife habitat. This technology produces highly accurate ground-level data, which drives better decision-making around the management, restoration, and planned use of natural resources. For this part of Nebraska, habitat protection translates directly into millions of dollars as tourists come to watch the wildlife along the Platte.
Colorado's URS Corporation is breaking new ground in research studies. Their Dartmouth Dam Piano Key Weir model study demonstrates potential for this new solution that began as a study for a project in Dartmouth, Victoria, Australia.